Hello friends, good afternoon. Myself Dr. M.H.ANNAIAH, Vice Principal at Saptagiri College of Engineering. And in today's session, friends, we have got the development of the lateral surface of a square pyramid which is cut by a horizontal section plane. Friends, you know very well, the square pyramid will have four isosceles triangles on its lateral surface and a square base. So when this is cut by a section plane, when this is cut along one of these slant edges and spread on a table, we are going to get a similar figure to like this. So we'll have 1, 2, 3, one more triangle, and all the dimensions we have here are all true dimensions. Now let me place the object on HP as per the given condition and then show the section plane. So here you have got a square pyramid having side of base 30 mm, 30, 30, 30. All the sides are 30 mm and it is resting on HP on its base with a short edge normal to VP. Four edges are there. 1, 2, 3, 4. I place the object on HP like this. The condition is also same if they say one of the shorter edge is parallel to VP or two shorter edges normal to VP. Here I will take this edge as the edge which is normal to VP. Get the top and front views as per the projection of solids. So the front view is going to be a square with the center O joined to all the corners, and the top view is going to be a square with all these corners joining and the diagonals are intersecting at O. So in the top view you are going to see a square base with the diagonals joined together, and in the front view you will observe a triangle. So let me start with the projections of the square prism. So I have drawn the XY line and mark VP and HP, and here I place the object on HP and obtain its top and front views. So the top view is a square upside 30 mm, and I am going to join these diagonals, corners representing these slant edges and mark O comma O1. O1 is the center of the bottom face, O is the center of the top face, and since this is a square, this edge AB which I am showing here is normal to VP. AB is perpendicular to VP. This is going to be C. This point is going to be D. This is the top view of the pyramid when it is resting with one of the shorter edges AB, say, is perpendicular to VP. So from the center, you just take the axis, mark the axis, dash dot line like this, and here this point is going to be O dash, the center of the vertex or the vertex of the solid. This is A dash, B dash. This is going to be C dash, D dash. Here C dash, D dash. Join O dash to A dash, B dash, and the O dash to C dash, D dash. This is the base of the solid. This horizontal line on XY represents the base of the solid. Let me mark the height. The height of the solid is 60 mm. This is shown from the base, and here this is a square. This is upside 30 mm. So I will say SQ30. SQ representing a square having 30 mm side. So all the sides are 30. Friends, I have got the front view a triangle. The top view a square with the center joint to all the corners. And now we have to see how the section plane is cutting this solid. He says the solid in this position is cut by a section plane which is normal to, section plane is horizontal. What is the meaning of horizontal section plane? The object standing here is cut by a section plane which is horizontal. Horizontal section plane is seen as a line above the xy. And this section plane is very obviously is perpendicular to the wall or the board, that is VP. So where does it pass through? It passes at a distance of 25 millimeter from the base of the solid. The base of the solid is this line. From there you mark a distance of 25 millimeter. It has given here 25 millimeter from the base. Base is this edge. So and mark the section plane passing through that. So I am going to make this distance or mark this distance as 25 millimeter from the base or 35 from this side. So I will show here this distance as 25 mm. That means the horizontal section plane SS is cutting the solid at a height of 25 millimeter from the base ABCD. Now friends, once the object or the solid is cut by the section plane, we throw away this upper part and we retain the bottom part and mark it as P. So P is the part that is retained for the purpose of drawing the development of the lateral surface. Friends, after throwing away these P's, the retained part of the solid is shown by visible lines. This is the part P that is retained. Now the projection of this solid is over and we have marked the section plane which is cutting the solid at a distance of 25 millimeter from the base, and now we have to draw the projections of the part P of the solid. Though the rule is same, the rule says in the development whatever the lines you get, the edges you get, they are all true lengths. And now friends, just see here if you see the top view, we have four slant edges, OA, OB, OC and OD, and none of these slant edges are parallel to wall or parallel to VP. So none of these slant edges give the true length of the slant edge. So in all such cases, we have a rule. It says whenever any of these are not parallel to VP, you draw a horizontal line through the apex, take one of them, that is take O as center, OD as radius, or O as center, OC as radius, any one of these, and just draw an arc. So by drawing this arc, we are making that parallel to VP, that's all. So from here, I write a vertical line till the XY line. I just get a point here. I am going to join that point to the vertex O. So this line will represent R, the true length of the slant edge, or is the true length of the solid, or the true length of the slant edge. So this is the procedure you have to make, not only in triangle, square, pentagon. In all the cases, whenever none of the slant edges are parallel, we have to follow this, and this concept will become very clear when you have some more sessions on the development of pyramids, and I am going to work out in all possible methods of having this section plane. Friends, we have got the front and top views of the solid. Now it's our duty to draw the development of the solid. So I told you, you have this slant edge R, take some point, mark that slant edge. The length of this O to this is R. So what is the length I have got here? Simply I have drawn here. It could be horizontal, it could be vertical. There is no definite rule for that. Then from here, with O as center, this distance as radius, you draw an arc. An arc. And then, you know the base of the solid is a square, and every shorter edge measures 30 mm. So taking this point as the center and this distance as the radius, keep marking 1, 2, 3, 4 such distances on this arc. Suppose say it goes up to here. So I will take 30, 30, 30, again 30. So these arcs are having radii of 30 mm. That is the edge of the bottom face. Join all these 4 points by thin lines. Join all these by thin lines to start with. This is 1, second, third, and this is 4. So you have on the lateral surface, you are going to have finally 1, 2, 3, 4 isosceles triangle, and here all the base edges are straight edges. So I am going to join all this by straight line from here to here, straight line, this straight line. So I have not marked any of the sides or edges of the solid. That we have to see the front view of the solid before you mark it. So this is R again and this is O. Friends, here you can see the section plane is horizontal. It is cutting the solid at a distance of 25 mm. We have removed this part and we are left with only this part of the solid. So the base is intact, and on all these 4 edges, OA, OB, OC and OD, the upper portion is removed and we are left with the part P, which is called the frustum of a pyramid. The frustum of a pyramid is that portion of the solid or the pyramid that is left over once the vertex part of the solid is removed. So if it is inclined at an angle, it becomes a truncated pyramid. If it is cut by a horizontal section plane, this part P becomes the frustum of that pyramid. If it is triangular, triangular pyramid. If it is square, frustum of square pyramid. Friends, you will observe very well that some part of OA, OB, OC, OD, that is this part is retained in all. And we have all these are cut by the section plane at these edges. So OA, OB is cut here. OA, OB are not the true length. OC, OD are cut here. OC and OD are not true length. So in all such cases, all these points where the section plane is cutting the solid are to be transferred to the true length line, that R line. So I have the R line here and I mark all these. So this is the measurement you have to take on all these. You know very well that OA, OB, OC and OD, they are all cut at the same height from the base. So now after getting this, you take the measurement, this measurement on OA, OB, OC and OD. And now you have the freedom to start the development either from A, B, C, etc. So I will mark it as A, this part as B, this is C, this is D and this is again A, because when you fold them together, A and A should come together. Now friends, let me take this distance and mark. So here, since all these distances are the same, you can take O as the center and this distance as the radius. We can simply draw an arc here. So what did I have done? I have taken this distance, O as center, I have made an arc. Now here friends, all these points are cut at the same height. So this is going to be a point, second point, third point, 4, again first points. And before joining them, let me mark them as 1, 2, 3, 4. This is point 1, 2, 3, 4 and last one is 1. And as I told you before, all the points so obtained after the solid is cut are to be joined by straight lines for all the pyramids, the prisms, the cubes, etc. So I am going to join all these by straight lines. That is 1 to 2, straight line, 2 to 3, straight line, 3 to 4, 4 to 1. I have joined this part. So let me transfer all these 4 points to this. So on OA, OB, you have 1, 2 here, and this you have got 3, 4. 3 and 4 are here, 1 and 2 are here. This part, the frustum is to be shown by visible line. Friends, as I told you before, this base is not touched by the section plane, hence the base of the solid is intact and all these edges AB, BC, CD and DA are to be shown by full lines. This is 1 edge, second, third, fourth. All these are straight edges from A to B, B to C, C to D, D to A. And now one more important thing is that the edges OA, on edges OA and OB, this much of portion is left over. That portion from 1 to A, 2 to B, 3 to C, 4 to D, and 1 to A, the last one, are to be joined by straight lines. And friends, if you see here, they have called this part as P, and this will give you development of P, the part or the prism of the square pyramid. You see an important point which is to be remembered. Friends, whenever these pyramids are cut by section planes which are horizontal, and here in the development the base will be intact, and all these lines which you are getting, that is 1 2, 2 3, 3 4, 4 1, they will all be parallel to the corresponding bottom edges, namely 1 2 is parallel to AB, 2 3 is parallel to BC, 3 4 is parallel to DC, finally 4 1 is parallel to AB. And this condition is valid for all the pyramids. And also remember, all these figures you get here, they are all same. This figure, this and these are same. And side 1 2 is parallel to AB, side 2 3 is parallel to this BC, side 3 4 is parallel to CD, and 1 4 is parallel to AD. And even if you are drawing the prisms of any other pyramid like hexagonal pyramid, pentagonal pyramid, or any other triangular pyramid, you are going to have a similar figure. So if it is a square pyramid, you will have 4 such figure. Pentagon, 1 more, 5. Triangle, 3, and so on and so forth. Friends, I hope you are all happy with the presentation I have made on the development of a square pyramid which is done by a horizontal section plane. And if you find this interesting, friends, do subscribe, inform your friends, share the information with all the known people, and have a wonderful day. This is Dr. M.H.ANNAIAH signing off.